acid-base solutions lab. Before we actually get started with any of the exercises, we want to make sure that our safety gear is in place.
So a few things that we have to put on before we come into lab. We have to have our goggles. We also, since we're working with acids and bases today, we have to be wearing our jeans because if we get anything on us, we want it to not go through to our skin. And then if it does go through to our skin, we're obviously going to wash it immediately. And if we have a large spill, we will talk to a TA. We also have to have our closed-toed shoes on, and preferably a little bit longer sleeves.
Since we're going to be testing the pH and concentration of our different solutions today, we will need to use a pH meter, and before we can actually use it, we have to make sure that it's reading our pH accurately. So we will first calibrate the pH meter. We're going to carefully remove it from this little case and making sure not to remove the cap. And we're going to rinse the stylus of the meter off with distilled water, and it's being washed into a waste beaker. Step 1 in calibration is going to be putting our stylus of the pH meter into the pH 7 buffer, and we're going to stir it gently, making sure not to bump the container.
Now we're going to calibrate on our LabQuest 2. So we're going to click this pH right here. We're going to go to calibrate, then we're going to go to calibrate now. We're going to click 7, and we're going to click keep.
Now that we've calibrated, what we're going to do is rinse the meter again, and we're going to make sure the calibration is accurate. So we're putting it back in the pH 7.
Okay, so we need 10 milliliters in here.
Now we're rinsing off again, making sure that it's an accurate read, and putting it into the pH 4 solution. And that looks good. Now that we have done our calibration to make sure our pH is accurate, we're going to rinse off the probe again and talk about why we use pH buffer. A pH buffer is a solution that resists changes with small amounts of acid or base, and so that's why we can use it to make sure our stuff is accurate.
So I'm going to talk a little bit about proton dissociation between like a strong acid and a weak acid. So in a strong acid, an example would be hydrochloric acid, and essentially it's going to completely dissociate. They broke up, they don't like each other anymore, they're completely separate. So you have like a plus hydrogen ion, and then you would also have a chloride negative ion, and they're completely dissociated. But however, in a weak acid, you're going to have acetic acid, and the ions aren't going to completely dissociate, they'll weakly dissociate. And so basically there's going to form an equilibrium because it's not completely dissociating, so it's going to be going back and forth the entire time.
Now we're going to get the pH of a substance where the pH is unknown, and we're going to use orange juice. Rinse the probe off with deionized water first. Ready? Okay, and now we're going to test the pH of the orange juice. And it looks like we're getting pH of 4.04.
Which would signal that it's an acid because it's lower than the kind of intermediate of 7. That's the separation between an acid and a base. After we wash the end of our electrode here with deionized water, we're going to put it up correctly in our solution here. We're going to make sure the head goes back down, but not all the way off. Then we will remove this connection here and place the machine back on its target.